we're going to be in this state 1, 2, 3, 4. We're going to be on a state 3. So our output voltage, it's going to be VDC over 2. When S2 is on, our output voltage, it's going to be negative VDC over 2, right? And then this is going to continue. Okay, so the waveform that we have looks like this. It doesn't look sinusoidal, but it's changing, right? So it's not constantly DC anymore. Actually, what is the DC value of this waveform? I want you to calculate that yourself, okay? And what is the RMS value of this waveform? You can calculate that yourself. Like DC, it's going to be 1 over T integral of 0 T dt. That's VO T dt. And the RMS value, it's going to be root mean square. Okay, so I want you to calculate both DC and RMS value of, sorry, there's no square here, the DC and RMS value of these, this output voltage. And then can we calculate the AC value of this signal? Yeah, it's going to be V of RMS squared minus what? V DC squared, right? So this is the RMS value of the AC. V sub AC, it's going to be square root of V sub RMS squared minus V sub DC squared, right? So this is how you can calculate. You can see that this signal actually has some AC value, right? So I leave it up to you to calculate this one and calculate this one, okay, and see like how much AC voltage you have. So this is all about half wave inverter. Let's look at the half wave rectifier. So I'm just gonna erase this. Okay, so in the let's look at the full wave rectifier, full wave inverter, sorry about that. Full wave inverter. Okay, full wave inverter, it actually has 4 switches and only 1 DC voltage source. So it has 4 switches. And this is our load. Okay, so the direction, the polarity that we choose for output voltage, let's choose this polarity. And the direction of the current, let's just choose this direction. But again, I repeat that the current can go this way or this way. If it's resistive, it always goes from this positive to this negative. But if it's a motor or like inductor, depends on the back EMF of the motor or the initial current of the inductor. So the current can be going in either of the directions. Okay, so let's now, and like the reason for this naming convention for the switches, it's similar to the reason that we had for a rectifier switch naming. So it basically shows like the order of the operation, and you'll see that a little bit later. But now let's look at the status of the switches. Now we have S1, S2, S3, S4, and we're going to look at the VO. Okay, we have 4 switches we can have 16 different states, but there is some limitation. We can't have both these two on at the same time. We can't have both these two on at the same time. So we actually like have a simpler case that we have only 4 states. So it's either this one on or this one off, or and then either this one on, this one off. Like these two cannot be both on at the same time or off at the same time. The same thing here. These two cannot be on at the same time or off at the same time. So let's just choose our table like this, 1 1 0 0. So if this is the case, if S1 is on, then S4 has to be off. Okay? And let's just choose this one 1 0. So if S2 is 1, S3 has to be off. If S2 is off, S3 has to be on. I'm just like showing 1 for on and 0 for off for the switches. Okay, and then when S2 is off, S3 is on. When S2 is on, S3 is off. Okay. Now, so this is the table that we have. Now, let's look at the waveforms. This one, I'm not sure if I would have enough space to do this. Let's just like try. I'm just gonna try my best to do this. So this is S1, S2, S3, and S4. So this is S1, S2, S3, and S4. And this is going to be our output voltage. So let's just like have S1 on for this much time and then off. Let me actually make it a little bit smaller so that I can show more pulses. This much, and it's going to be off for this much. It's going to be on for this much and off for this much. And now I can actually do S4, because when S1 is on, S4 has to be off, and then when S1 is off, S4 has to be on, and this would continue. Okay. Also gonna choose S2 to have some phase lead from S1, and there are different kinds of way that you can turn like S1 and S2 like have on compared to each other. That's like depends on the modulation that we're gonna use, but let's just like assume that this is the case for S2. And this is how we have S2, and S3, it's gonna be the opposite of that, right? So it's gonna be off when S2 is on and on when S2 is off, and this would continue. Okay,